So let's say that I had this equation and what I was trying to do was to solve for x. If a and lambda were numbers, then I could just subtract this over here. So if I think about doing that, I'd have ax minus lambda x is equal to 0. But the challenge here is that we know that a wasn't a number. A is actually a matrix. I don't know what I was trying to say. Rewind. So A is a matrix, lambda is a number. If I were looking at this, if a and lambda were both actually numbers, then I could just do this subtraction, or I could think about factoring that x value out. Because the order of multiplication matters for matrices, it's important that I would be factoring that x out on the right-hand side. So I'd end up with an x over here, and this would look like a minus lambda. Here we have a problem because a is a matrix, but lambda is a number. And I can't subtract a number from a matrix. So we actually have to rewind here and think about this instead with an invisible identity matrix squished in there. Now, we know that the multiplicative identity for matrices is this identity matrix. So it won't change x when I multiply I times x. The only purpose it serves is so that when I factor out x as a vector, what I end up with is a matrix minus a matrix. Okay. Here's where life gets interesting, and this is why we had to know something about inverses. This right here is a matrix minus a matrix, which means the result is going to be another matrix. So I'm just going to call this some matrix B for a second. So now I have this equation that Bx is equal to 0. Well, if Bx is equal to 0, then we should be able to solve this by multiplying both sides by B inverse. So on the left-hand side, I've got B inverse B times X, and that's going to be equal to B inverse times 0. Now, looking at this, B inverse times B, those are going to cancel out. I'm just going to be left with X is equal to, well, something times 0 is 0. The only way for this to not be true is if it wasn't valid for us to use B inverse in the first place. And we know that B inverse doesn't exist anytime its determinant is equal to 0. So it turns out that the way to find these eigenvector eigenvalue pairs is by ensuring that the determinant of B is 0, so that B inverse does not exist and all the critters aren't dead. So we're going to cut it off right at this point and instead say, let the determinant of A minus lambda I be equal to 0. This right here is the secret for how we're going to find our eigenvalues, how we're going to solve for that lambda.